Hey guys, let's discuss new problem from stack topic, which is find the largest rectangle in histogram. Okay, so you would be given array, and each element of that array will represent the histogram bar, whose width is 1 unit. Okay, and height is the given element. So for example, this is my one chart. So for example, this is 2 height. Okay, 1 height. So I need to find the largest rectangle. Okay, which whose area is the largest. So for example, see here one rectangle is forming. We are forming one rectangle. If the height of this is 2 and this one is 1, so the area of this rectangle is 2, right? But here if you check this rectangle, this one, right? So here this one is 5 into 2, 10. So 10 is the largest one. Okay, if you find anything, 10 would be the largest. So our answer would be 10. So we need to find this. So if you check here, see, there is a concept of previous smaller element and next smaller element. How? If you wanted to know rectangle for let's say this bar, okay, so I will calculate area, I will include bar, okay, until I don't encounter the previous smaller element. So for example, for this 5, if you check for this one, see, I haven't taken this left hand side bar in my calculation. Why? Because this is lesser than the current element. Okay, and same if you check for right hand side. So I took this one because this one was 6. Okay, so 5 is greater than 5 is less than 6, so I took this one. Then again 2 is lesser than 5, so I haven't taken. So I need to, so what I will do, I will just find the previous smaller element and next smaller element. Okay, and for example, okay, let's check that. What I will do, first I'll create one stack. Okay, and then I will iterate this array. So 2 will come. Okay, now stack is empty, so I'll put this 2 into the stack. By the way, we will put indexes, but for our calculation I'm putting element comma index. Okay, so element is 2 and index is 1. Now second 1 will come. Okay, so we need a smaller element. Okay, and I just saw that there is a larger element than 1 in the stack, so I will pop it. Okay, but before popping it, I will do some calculation, because here we are not using two different array for left or right counter to save, right? We are calculating next smaller element, previous smaller element on the fly while we are traversing the array. Then in that case only we will have a space complexity order 1, right? Because we are not using any extra space. So if you check this one, okay, if you check this one, then 1 is less than 2, correct? Condition true. So what you will do, you will pop this element from stack. Okay, so you will pop this element to stack, but you will take its so you'll take one variable height and you will just assign this value 2 to that height, and then you will pop this element. Okay, now your right boundary right now will be the current I for which you are iterating. So we are iterating for this 1. Okay, right boundary will be 1, and what will be your left boundary? Left boundary will be the current element of the stack dot pick, whatever will return you. But right now my stack is empty, so I'll take -1. So right boundary will be -1. So right boundary minus left boundary minus 1, okay, will be my width. So right boundary is 1, left boundary is -1, and then -1. 2 minus 1 will be 1. Okay, so my height is 2 and width is 1, so my area would be 2, and I'll take one max area variable. Okay, initially 0. Now I'll check which one is max. I'll assign that value to max area. So currently it is 0, so 2 is greater than 0, so I'll assign it to 2. Okay, now that's and then I will push this current value, which is 1 comma 1, into the stack. Okay, now let's check for another variable. Let's do same thing for another variable. Okay, so next this 5 comma 2 will come. So 5 is greater than 1. Okay, so that is fine, I can push it. 5 comma 2, then 6 will come, means the third variable. Okay, so 6 is again greater than 5, so that's fine, I can push that into the stack. Okay, now this 2 came, or fourth index. Okay, so 2 is lesser than 6. Okay, now here we need to process our array stack. What I will do, I'll pop the element from stack, but before popping I'll assign this element value in height. So my height would be 6. Okay, now I remove this 6 comma 3 from stack. So my right boundary will be my current index is 4. Okay, my left boundary will be stack dot pick. Okay, so stack dot pick is 2, so 2 will be my left boundary. Okay, so right boundary minus left boundary minus 1, what will be the answer? 4 minus 2 minus 1 will be 1. So height into width, 6 into 1, area would be 6, so max area is less than 6, so I'll assign this 6 to max area. Okay, now and then I will push this 2 comma 4 into the stack. So 2 comma 4 is here in this stack. Okay, fine. Now next element will come. So next element would be this 5. No, by the way, before taking next element, I'll not push it. Okay, let's see. I cannot push right now because here we have a while condition. Okay, here we have a while condition. So currently we check for one element. Now check again that current height. Okay, so our current height is 4. So 4 is less than whatever there on the stack. Stack.pick is 2. So height of 2 would be 5. So 4 is less than 5. Condition is true. So we need to do same thing for this 5 comma 2 also. Okay. So height will be 5. I will remove this element from stack. Okay, and then my left RB will be 4. Right boundary, left boundary will be what I have in stack. So 1 comma 1. So this 1 will be my left boundary. Okay, so what will be my new width? 4 minus of -1. Okay, -1, not -1, 4 -1 -1. So 2, 4 minus 2, 2. Okay, and my height is 5. So 5 into 2, my max area will be 10 now. So I'll update it 10. Okay, now I can push because now I have here 1. So 1 is less than 4 is less than 1. 2 is less than 1, right? We are doing this for 2. So 2 is less than 1, condition false. So I can put now 2 comma 4 here. Now next element, we'll do this for 3, element 3 and index 5. So element 3 is less than 2, condition false. So we will push this 3 comma 5 in stack and I plus plus. So our iteration is completed, and whatever we have in max area will be our answer. So it will be 10. So if you check the code, I'm doing pretty much same thing only. Okay, we have taken one stack, we have taken max area initially 0. Okay, n will be height of the length of the height array. Okay, and then we are iterating with for loop. Current height will be height of I. Okay, and then we are running one while loop, and this while loop we are checking if stack is not empty and my current height is less than height of whatever element there in the stack. I'm telling you again that we are storing indexes in a stack. Element we are not storing. Just for our just for explanation, I have added element comma index. Okay, now I'll check. I'll pop the element from stack and will initialize height. The current height. Okay, height of that index in height variable. Then my right boundary will be I, my left boundary will be the stack.pick. If stack is empty, then -1, and then I'll find the width with the formula right boundary minus left boundary plus 1, and my max area, and then I'll update the max area. If this condition is false, while condition is false, then I will simply push that element into the that index into the stack. Okay, and at the end I'll just return the max area. That's it.